Jai Jirendra, Namaste. My name is Sayyam Jain. Welcome to my channel, Learn, Grow and Enjoy. So, this is the second question of the problem solving series, the placement series based on array. And this question has been asked in my Amazon, and the difficulty level for this question is easy. So, the question is given a number n, we need to replace all zeros in n and with 5 and return the new number. Suppose the number is 5012, so we'll replace this 0 and we will return 5512 as the answer. 23, we don't have any 0, so we'll be returning 23 only. 200705, there are 3 zeros, so we will convert it to 255755. So this will be our answer. So how do we solve this? What is the intuition? How do we reach this 0? If this is a number, if this would have been a string, then we could have replaced this 0 character with 5 and we could have returned this string after replacing this all the 0 values, but this is a number. So we can convert it into a string and then we can replace the 0 character with 5 and then again we can convert the string to integer and then we can return it. This is one solution. So in C++ we can convert using this library. We'll convert the value to string and then we will use that check whether the character traverse the string and replace the 0 character with 5 character, and then again we will return the converted string to integer, this thing stui, and we'll have a solution. So this is one solution, but is it an optimized solution? The time complexity to convert the number to string and string to integer is order of n, so the time complexity is not too much, but not order of n, the order of the number of digits which this number has. But this kind of functions generally in the interview they don't suggest to use toString or stui. So suppose if the condition is mentioned that you shouldn't use any library, then what would be our solution? Do we have any other way to solve this? How can we reach this? How can we convert this 0 to 5 and then we can we will have our new number? How do we return this? What is the intuition? So you guys would have solved palindrome, check whether a number is palindrome, check whether a number is Armstrong number. So what do we use? What algorithm do we use there? We use modular mathematics. To get to the unit digit, to any digit, we just use the mod 10 operation on that number and we get into the unit digit. So we'll use the same here. We'll get every unit digit, we'll get to every unit digit and we'll check whether the number is 0 or not. Once if the number is 0, we'll change it to 5, but then we will have to get the real number. For example, if this is the number, if we do a mod of this, then we will get 2. We'll check whether 2 is not equal to 0. So then we will store 2. And now this number is 5012. We need to go to this 501. So we will divide it by 10. Then we will, if we divide it by 10, the number becomes 501. And then again we take mod of 10. We get 1. 1 is not 0. So we will store this 12 thing in another variable. Again we will divide it by 10. And then we will check whether it is 0 or not. It is 0 once we do the mod. So we'll change it to 5. Now, to make this 12 to 512, we will have a converter, a decimal, which since we are dividing it by 10 every time, we will multiply the decimal by 10 every time. So that this new number becomes 5 into 100 and then this will plus this 12. And again we will multiply it by 1000. So that when we reach here, then we will have that 5 into 1000 and this would be our number which we will add and we'll get the answer as 5512. So this is the solution. Let's do the pseudocode for it. Is there any edge case in this? Yes, we will be, what would be the termination case? We are going to 2, 1, 0, we are changing the value of n by dividing it by 10. So a time will come that the n will become 0. So that would be the termination condition. So if n is given as 0, then we will not reach that part of our loop. So we will have the edge case that if n is equal to 0, what would we be returning? We will be returning 5, not 0 or not n, because we need to convert the 0 with 5. Now, else, the logic what we have discussed now, we will implement this. While n not equal to 0, now we need a answer. So we'll have an answer variable which is 0. We will have a decimal value which is 1, and we will have a mod which is 0. Okay. Now, okay, this should have been declared before this loop. Okay. Or we can declare it over here. Anything is fine. Int answer equal to 0, decimal equal to 1, mod equal to 0. Okay. Now what we'll do, we will check this value is 0 or not, mod n mod 10. So mod will be 5012. If we take the example of 5012 mod 10 would be 2. Okay, so we'll check if mod is equal to 0 or not. If it is equal to 0, we will make mod equal to 5, right? Now, what would be our answer? Answer would be answer plus mod into decimal. So here, if suppose only 2 was the number given, so 2 mod 10 would be 2, and our answer would be answer plus 0 plus 2 into 1, that is 2. And then 2 will be divided by 10, 2 will become 0, and we will break this loop, and now we will be returning. But our question is 5012. Also, now we will update the value of decimal. To reach to this value, it should be multiplied by 10 every time. So we will keep on multiplying this by 10, and to get the new number mod, we need to divide n by 10, and we will return answer. This answer will give us the value. Let's try run it for 5012. We have already done it for 2. Now, after this, our n value will become 501, and the decimal value will become 10, right? So we have our answer as 2 right now. Our decimal is 10, and our n is 501. Okay. So now again, since 501 is not equal to 0, what we'll do? We'll do a mod of 501, and our mod will become 1. Mod is not equal to 0, so we will get the answer value as 2 plus mod into decimal. So mod value is 1. So 1 into decimal is 10. So 12. Answer has become 12. The decimal value will increase to 100, and the n will become 501 by 10 is 50. Right? Now 50 is not equal to 0. So 50 mod 10, we get mod is 0. Since mod is equal to 0, mod will become 5. What will be our answer? Answer would be answer plus mod into 10 decimal. Answer's value was 12. So mod is 5 into 100. 500 plus 12. 512. And the decimal value would be now 1000. And the n value would be now 50 divided by 10 is 5. Right? Now 5 is not equal to 0. Again 5 mod 10 is, mod is 5. Answer would be, we don't need to convert, it's already 5. Answer would be answer plus mod into decimal. That means 512 plus 5000. 5512, decimal would become 10,000 and would become 0, because 5 by 10 is 0. So our condition will be terminated. What is the answer's value? 5512. So this is the solution. What is the time complexity? Time complexity is the number of digits in n. That is, if the number of digits is k, then the time complexity is order of k. What is the space complexity? We have taken 3 variables only, so this is order of 1. So this is the solution. The link of the question has been given in the description. I have explained the whole solution. You can code it and you can verify it by after you code it, you can verify the code walkthrough now.
So here is the code walkthrough of the second question. Replace all zeros with 5. So here we are checking the edge case. If n is equal to 0, we must be returning 5, and if it is not, then we'll be going to this modular logic where we are converting the mod value to 5 if it is 0. Here we have declared the values over here, okay, and we are multiplying to get the mod with the correct value whenever it goes to any part of the digit of the number, and we are dividing it by 10 every time. So this is the answer, and let's compile and run it. So we can see this is working fine. Let's submit it. So this is worked. So the time complexity as discussed is order of the number of digits, and the space complexity is order of 1, as we have taken only 3 variables. So let me know in the comment section how was the explanation, did you understand it or not, and see you all in the next video where we'll be solving the third question of array. Jai Jinendra.